Yep, so we solved this problem before. So let's continue with the number 9. Yeah, so we want to find the original point. So that means we are going backward. There are two types of transformation here, and first one is rotation, and second one is reflection. But because we are going backwards, we are going to apply reflection first. So if the end point is minus 6 and 3, if it's reflected back with this line, what will be the intermediate point? Coordinates of the intermediate point is,
Y equals minus 6.
let's just
3 minus 6.
yeah, kind of, let me see. So let's use the graph. Mm, like this. So minus 6 and 3 is about here. And this is the graph of y is equal to minus 6. So that means the dew point will be here. And the dew point coordinate is, yeah, minus 3 and 6. And then this point will be rotated uh, around the point 1 and 5. So let's make 1 and 5 is here. So if we rotate this one 90 degree. Oh. Yep. So let's say this is 90 degree. And what will be the new coordinate? So we can make this right triangle like this. Okay, so two legs are 1 and 4. So that means this one will be also 1 and 4. So now what's the new coordinate? If we move this 1 and 5, the
Mm-hmm.
1 unit to the right and 4 unit up, the new coordinate,
Oh, 2, 9.
yeah, 2 and 9. Yeah, that means okay, so A is 2 and B is 9. Yeah, so what's B minus A?
B minus 5.
Yep. If A is 2 and B is 9,
From 7.
yeah, 7. Yep. Yep. I think you can solve this problem. Just tell me your answer.
Okay.
Yep.
Uh, D.
Let me see. But you need to divide this 1 over 3 because left one is.
Oh, hold the
Yeah.
lender. Oh, sorry, I misread the
Okay.
equation.
Yep.
Oh, 1.5, so A.
You're right. Yep. Yep. Oh, not this. Yep. So these are brownies. Cut pieces of brownies. So in interior there are L times W number of brownies.
Okay.
Okay, okay. Yeah. So for interior, there are L times W number of brownies, and this outs the border brownies also has the same number of brownies. That's the condition. This sentence means that means because border is perimeter, we can use the formula to get the perimeter. That's this. No, 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 not this way. Uh, Yep. Okay. Yes. So border contains this way, and they have the same number, so we can make the equation. And we can factor the left side because L and W's are integers. What can be the value of L and W to make 8?
Where did the 8 come from?
This 8. When you open this, this comes out when you open the right side parenthesis, and then I deliberately add 4 to both sides. So 4 plus 4 is 8. I add 4 to both sides because I wanna make this factoring on the left side.
Oh, I see.
Okay, yeah. So which one makes more brownies? 4 and 6 or 3 and 10?
Hmm? Oh, 3 and 10.
3 and 10, so that means inside there are 30 pieces of brownies, and uh, also outside, because it has the same number of brownies. So what's the total number of brownies? So
Oh, 30. 60.
yeah, 60 is the answer. Yep. No, no, sorry. Oh yeah, so because we can expand this two cubed to the sum of one, two, four, and eight. How can I say? Not this way. If we wanna make the divisors from two cubed, we can make these divisors factors. So that means if we multiply one to the rest, that will be the odd divisor. I mean, we can make odd divisors with it. But if we multiply these even numbers to this product, they will make the even divisors. So if we want to find the ratio, it's like 1 is odd and uh, the sum of 2, 4, 8, they make the even divisors. So which one is the answer? Which one is the ratio? So what's the sum of 2, 4, 8? Oh, can you hear me? Yeah.
Yes. Sorry. 14. One
Yes,
over 14.
sum of 2, 4, 8 is, yeah, 1 over 14. Yep. So the answer is C. Yeah, so what's the value of D?
D 70 equals 14 2.
2. So if D is 2, what's the value of N? If we use first equation.
Give me a second.
Yep, I'm also solving it. Yeah, take your time. What is it? 261? Oh, okay. So N is. Yep. If it's we can factor this way. What's the value of N? I mean, which value of N makes this parenthesis 0? Oh, can you hear me? Can you find the value of N? Yeah.
N equals 9
Yep.
or
Yeah, 9, 9. Yeah, but this one doesn't make sense. N is should be integer. So yeah. So what is the N plus D?
N
N
plus
plus
D.
D. Yep.
11.
Yeah, 11. Yep. So now we can make a two Pythagorean theorem for because there are two right triangles. Uh, for the triangle which has the 17 side length, we can make this Pythagorean formula. And for the triangle which has the 19 side length, we can make second Pythagorean equation. So we can subtract these two equations. Yeah, so what's the value of D?
Uh, D
Yeah,
six.
yeah, D is 6. And oh yeah, so the answer is 6. The distance between two lines is 6. And this is a half of the distance because uh, there is another half here, and this thing is D, so because they are equally spaced. We can take x to the 7th power out, and if we spare the first equation, sum of the squares is 3, and we can make another square for this with this equation. So if the sum of the first power is 7, this parenthesis becomes 0. So what's the total value? Can you find the answer? If this parenthesis is 0, uh,
Parentheses is 0.
yeah.
Oh, x cube, x to the power 7.
But if you multiply,
Oh, yeah, 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 0, 0, 0. 0.
yeah, 0, it just becomes 0. So the upper integers are made of 2 digits. 15 and 45, they are upper integers divided by 15. And can you think of upper integers with 3 digits?
Of what integers?
Yeah, upper integer. Upper integer means, I mean, it's increasing order. So how can I say? So for example, this type is a kind of upper integer because it increases from 135, right? And it's divided by
Uh,
15. So that's
one.
yeah. Yeah, can you think of other upper integers with 3 digits?
Oh, this is about 15. 100. Oh, can you give me a moment? I think
Yeah,
my.
okay, yeah, yeah. Yeah,
Yeah.
take your time. Yeah. Yeah, this is another the upper integer with 3 digits. Can you make 4 digits?
Oh, sorry. I was trying to find my dad.
Okay, you're dead. Yeah.
I am okay now. Yes,
Okay,
yes.
yeah, okay, yeah. How about 4 integer? 4 digits. Something like this, right? Uh, uh, Six, seven, nine. Mm, is there any other number? I mean, 15, 40. Okay. To be a multiple of 15, it should be a multiple of 5 and multiple of 3. And to be a multiple of 3, the sum of the digits should be a multiple of 3. So 1, 4, 7. Okay. I think we can make this way because the three-digit sum is 4. But this is not increasing. It should be strictly greater, not this. Hmm. Uh, Maybe this five, and no else. But there may be some other numbers. Uh, uh, Let me see. Uh, one more. One more is yeah. Okay, okay. 1, 2, 3, and 5. Yeah. Uh, yeah. 5 digit is also possible. Yeah. Yeah. This makes this 10. Yeah. Yeah. 6. Hmm. Yeah. So which statement is true?
Hmm?
Yeah. If we make this sum using these cards, which statement is true? So Ray, I mean, is statement A is true? Does Raven?
Uh, yes. Wait. No. No.
No. Yeah.
Hmm. Oh, Raven was given code for so C.
Yep. So let's say we have this n trial, and before odd number appears, and they should have every even number. They should contain. So that means there are three even numbers in a die. So if we make the n number of trials, there will be the 3 to the nth power, the even numbers. What is But this contains the case only two even numbers appeared. So we need to subtract this 2 to the nth power. But this 2 to the nth power also contains the case only one even number appears. So if we want to strictly subtract the case when two even number appears, we need to subtract the one the case when only one even number appears. But in this case, because we are talking about two even numbers, we are multiplying number 2. It can be one of the two numbers. And also, if we want to subtract the case when only two numbers appear, we choose two numbers out of three even numbers. So the number of choice is 3. I mean, there are 2, 4, 6. So we can choose 2 and 4, or 4 and 6, or 2 and 6. So there are three cases. So we need to multiply 3 here. And then we also need to subtract the case only when only one number appears. So we need to subtract this 1 to the nth power. And because there are three even numbers, we also need to multiply 3 here. Uh, and we start uh, the num the number of trial with 3 because uh, in this case one trial or two trial doesn't make sense because to make every even number appears because there are three numbers, the minimum number of trial is 3. So we start from 3, and then this sequence goes to infinite. I mean, before odd number appears, there may be the infinite number of trials, and the total number of cases, if we try n times, is the 6 to the nth power because there are 6 numbers. So if we want to find the probability, we need to divide this by 6 to the nth power. And after this, the odd number should appear. So what's the probability that odd number appears? When you throw a die, what's the probability that
Uh,
odd number
one half.
appears? 1/2. So we need to multiply 1/2. So we need to calculate this, and for this we are using the infinite series. Yeah, there is a formula to find the infinite series. So we can first simplify the parentheses. And we are going to open the parentheses. And then we are going to use the formula for the infinite series. That means let's say this way. The formula is this, and in this case, the r should be less than 1. I mean, the absolute value of r should be less than 1. And because they are all less than 1, we can use this formula. And in this case, the first term is when n is 3 instead of 1. So that means the first term is the 1 half cubed, like this. This one too, when n is 3, the first term is 1 over 9. For this one, the first term is 1 over 72. Hmm. Yeah, can you add these three fractions?
Yes,
Yeah,
this
you have
is
added these three fractions.
four, five, five, six, 6/60.
Let me see this. Yeah, wait a sec. Let me think. This is 15. 15. Oh yeah, something like this, right? Yeah. So uh, the final product is 1 over 20. Yeah, yeah, that's the probability. Yep, yep. 내가 뭘 예. Yep, so I think we can solve this to find this value. Yep, so what's the value of n?
Oh, minus it. Oh, sorry. 10, 10,
Yeah,
10,
when you solve this equation, n is
10.
yeah n is 10. So if n is 10, we can use the second equation. Yeah, what is 35 times 8?
280.
You're right. And okay, but still. So let's use first equation. If n is 10, yeah, what is 32 times 9?
Oh, uh, 280. Oh, 200, 288.
Yep. So Once again, subtract. So B is 8. So what is A if B is 8?
What is A and B is 8?
Yeah, B is 8, so A is 80. So now, what is S?
S, A, B.
From here, S is, if A is 80,
Oh,
yes,
S equals 342.
yeah, 368, because we are adding 80 to 288 to find S.
Minus A minus B minus B.
I'm using this equation. If I,
Oh,
yeah.
I was using S minus A minus B.
Okay, yeah. So, and then, so the value we want is like 368 divided by 10. Yeah, so which one is the answer? Uh,
What is
yeah, from the choices, options,
S? 368.
divided by 10 is,
Oh, D.
yeah. What is this angle? Measure of this angle. Uh,
E.
yeah, this one is 60 because they are all equilateral triangles. This, I mean, yeah, angle is the 120 degree because 2 times 60, 120 degrees. Yeah, and let's say so half of this is 60 degrees. I mean, they are equilateral triangles. And then the side length is 2. So that means, what is this length? I mean, we are using the special right triangle here. Uh, this one is. So half of equilateral triangle means.
30.
Okay, so 1, I mean, and then this height of the triangle is, if we use Pythagorean theorem, this
Oh,
one,
square root of
yeah, square root of 3. So same thing here. So this one is also square root of 3. That means the length of AD. The length of AD is the 2 times the square root of 3. And this length is also 1. So we can make a big Pythagorean theorem here. So what's the length of the big height?
Um, height.
Yeah, height. Let's say this point is m. So what's the length of AM?
Root of 2 square root of 3. Square root of 11.
Great. Yep. So that means we can make another segment here. Yeah. So, uh, yeah. What's the area of ACD? The center triangle. Uh,
Square root of 11 times square root of 11.
yep. Oh. And what's the area of AED?
AED.
Yeah, the right triangle here, the obtuse right triangle.
One time. Oh, just square root of 3.
Great. So that means the same thing goes to the ABC. Yeah, so the sum of these three triangles are the area of this pentagon. So what will be the value of m and n? Let's say m is 11. In such case, what's the value of n?
Of n.
Yep. When you add these three, what will be the value of n?
Which 3? N?
I mean, I'm talking about this. What is the, let's say,
Oh, n. Sorry,
yeah.
sorry. Uh, square root of 11 plus 2 square root of 3. Is there a way to put that into one radical? I do not have a calculator.
But you might not need a calculator. I mean, this one. So, can you make this two inside the square root? This one is equal to square root of which number?
Square root of 2, 4 root of 3.
Yeah, I mean.
Oh, right, it just goes inside.
Yeah.
4 root of 12.
So that means, n is this one is.
12.
Yep. So what is the sum of m and n?
Square root of 11 plus,
Uh,
23.
yep. Yep. Yeah, another geometry problem. So we can make a Pythagorean theorem using this triangle. So what's the value of x?
Oh, minus 2x, 2x equals, x equals 5, 1, right?
Yep. So on this left triangle and right triangle are similar. So okay. So what's the ratio of similarity between left and right?
Between left and right.
Yeah. The ratio is. Uh, Let me see. So if this angle is theta, this one is theta. So it's like the ratio is. We need to compare these two. So 3 and 2, right? 3 and 2, 2. So for the perimeter, what's the perimeter of the right triangle? The smaller triangle?
Perimeter of triangle AC.
Uh,
2, 3, 8 over 9. 12,
yeah, this triangle.
um, AEC.
Let's first find this perimeter, the smaller one. This one.
Oh, the ratio is 2. Give me a
Yeah,
second.
okay, yeah.
Uh, 14 over 9.
Four.
Oh, wait, no, there's
Uh,
a height. 16, 16, 26 over 9.
okay. I mean, so when you add these three, that's the 4 over 3. I mean, when you add these three numbers. Uh, okay. Yeah. So and then because the uh, scale factor is 3 to 2, the bigger parameter, will be multiply the 3 over 2 to the smaller parameter. So I think it's exactly 2. Maybe 2 like this. Let's see. Yep, 2. Yep, so in this case, we want to find the case when at least one box contains all the same colors of three balls, three blocks. So let's first choose the color. Because there are five different colors, the number of cases for choosing the color is 5C1. C means computation in this case. And then we are going to put this color into one of the five boxes. So the case for choosing the box is 5P1. We assume these boxes are different. So after filling one of the boxes with the same color, the other four boxes, we can make any type of arrangement. So because there are four blocks remaining for each color, the remaining cases are 4 factorial. And because there are three colors, we are making cube. However, this case contains uh, the case when two boxes have the same color. Because we are making random arrangement for the remaining blocks, this random arrangement must contain the case when additional box contains the same color. So we need to subtract the case when two boxes contain the same color. So when you subtract, we first need to choose the two colors out of five. So the number of cases is 5C2, and this two color goes to the two boxes. And for the arrangement, we need to multiply 5P2. And then for the remaining three colors, we can make random arrangement. So this case is 3 factorial. And once again, this cubed because there are three colors. However, this one also contains the case when three boxes contain the same color. Because of this random arrangement, there will be additional box containing the same color. That means because we are subtracting the case, three colors are subtracted. We are adding back uh, the case when three boxes contain the same color. So we need to choose the three colors out of five. So 5C3, and then we choose three box. In this case, that becomes 5P3. And for the remaining two 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 blocks, we are making a random arrangement and cubed. And because this case also contains the four cases, because of this random arrangement, there will be additional box containing the same color. And that will make the total of four colors having the same, four boxes having the same color. So we need to subtract this because we want to strictly add the case when three boxes contain the same color. So we need to subtract this fourth case, and there is one more case because of this arrangement. And now the all five boxes contain the same color. So because that's subtracted, over subtracted, we need to add the case back. So now there are no more case after all boxes contain the same color. And the total probability is the 5 factorial cubed. So to find the probability, we need to multiply 1 over 5 factorial cubed. So if you open the parentheses, zero factorial is 1. So if we simplify this expression, uh, uh, something, something is not right. Something. Oh. Yeah, this is the probability. So, what's the sum of numerator and denominator?
Hmm?
Yeah, what's the sum of numerator and denominator?
Sum of new 471.
Yep, so the answer is D. Yep. Yep, I think we can stop here because this problem is difficult. Let's do it next time. So let's meet this Sunday for the calculus. Yep, so that's it for today.
Okay, bye. Have a good day.
Have a good day. Bye.